Hello students, how you are? This is your Prabhakar and welcome to my class Dawn of Chemistry. Hope all of you are happy and healthy in your homes. And today we are going to discuss about the most energetic topic, that is oxidation number. See, oxidation number. This is the most vibrating topic and most energetic topic we will be having, and the most important topic also. See, what is this oxidation number concept? See, where we get questions in this oxidation number concept. In advanced exams, definitely you will be having relation questions based on this oxidation number. In a mains exam, NEET exam, definitely you can expect one question, even in mains as well as in NEET exam also. Even in the local set exams also, you will be having the questions based on this oxidation number. This is the very interesting topic and very simple topic also. Let me get into the details, and it will be confusing topic also for some students. Let's get into the details of this oxidation number. See, for any element, oxidation number means the charge present on any atom when the other elements in a compound are removed. So see, the charge present on any atom when the other elements in a compound are removed is known as the oxidation number. Or simply speaking, number of electrons lost by the atom or number of electrons gained by the atom during formation of compound is called as the oxidation number. Let me give you an example. H2O you take. Let us consider for oxygen. Here in H2O, hydrogens will be in the form of H plus. When you remove the 2H plus, you will be having the oxygen which will be bearing the minus 2 charge will be bearing on that thing. So here that minus 2 charge is there, right? This minus 2 is known as the oxidation number of this. So, and go to the another one, CO2. Here the oxygen will be present in the minus 2 state. Here if you remove the 2 oxygens from this compound, carbon will left over. So the leftover element bearing the charge is nothing but the oxidation number. Hope you are clear with the definition. Charge present on any atom when the other elements from the compound are removed is known as the oxidation number. Simply speaking, electrons lost by the atom or electrons gained by the atom during the formation of compound is known as the oxidation number. Electrons lost means positive oxidation number. Electrons gained means negative oxidation number will be present. So if any element, here you see hydrogen is having positive oxidation number, that means it is lost electrons during the formation of H2O. Here carbon is showing plus 4 oxidation state. So to form the carbon dioxide, carbon lost 4 electrons. Here you see oxygen is bearing minus 2, that means to form H2O it gained 2 electrons. Even in carbon dioxide also you see, to form the carbon dioxide, oxygen gained the 2 electrons. Like this, oxidation number gives idea about the whether the element lost electrons or whether the elements gain electrons during the formation of the particular compound. So what is the significance of this oxidation number? Let's get into the details. Oxidation number helps to identify oxidizing and reducing property. Oxidation number helps to identify the oxidizing and reducing property of a particular central atom or particular compound. Next one, oxidation number is 0 fractional also. Oxidation number can be 0 and fractional also. Next you see, for any species, algebraic sum of oxidation states of all elements in it is equal to charge on species. So for any species, if you take carbon dioxide, algebraic sum of the oxidation states of the elements is equals to charge present on them. Let us see here, carbon dioxide, carbon oxidation state is there and oxygen oxidation states are there. The total charge on them is equals to 0. Here also in H2O, hydrogen total oxidation state and oxygen total oxidation state, if you club them, total will be equals to 0. If you consider CO3 2 minus and NH4 plus, what you can conclude for these things? In carbonate ion, the algebraic sum of the oxidation states is equals to -2. In NH4 plus ion, algebraic sum of the oxidation states is equals to +1 will come like this. We can study about the oxidation number. Let's see this. What is oxidation number means? The charge present on any atom when the other elements in a compound are removed. In any compound, the charge residing, if you want to find oxygen oxidation number means you have to remove the other elements. If you want to find the hydrogen oxidation number means you have to remove the oxygen, like that. Whatever the compound you take. Let us take for example KMnO4. In this KMnO4, you want to find the manganese oxidation state means what you have to do? You have to remove the oxygen atoms and you have to remove the potassium atoms. Whatever the charge remains on the manganese, that will be the oxidation state of the particular element, like this. Charge present on the atom after removing the all other elements from the compound is known as the oxidation number. Oxidation number gives idea about the electrons lost or electrons gained by the element during the formation of the particular compound. What is the use of this oxidation number means? Oxidizing and reducing property of the particular substance you can explain, and oxidation number can be 0 and fractional also. For any species, algebraic sum of the oxidation state of the element is equal to charge on the species. This is the basic introduction of the oxidation number. Here you should not confuse with the valency and oxidation number. Here the valency is its capacity to react with equal number of hydrogens, equal number of halogens, or double the number of oxygens or triple the number of nitrogens is known as the valency. Valency can never be 0 except for inert gases, and it can never be fractional also. But oxidation states can be 0 and fractional also. But valency can never be negative, but oxidation state will be negative also. The valency is a constant number for a particular element, but oxidation state will be varying for an element in different circumstances. Now the most important topic in this oxidation number is calculation of oxidation number. Calculation of oxidation number. So let us see, sir, how can we calculate the oxidation number for any species? Are there any guidelines? Means, so to calculate oxidation number of any species, there are certain rules are formulated. Let us see what are the rules to calculate the oxidation number. See the first one, for all elements in elemental state, oxidation number is 0. Let's take S8, O3, O2, P4, O2, already over, N2, H2, anything you take. even sodium, potassium, rubidium. Anything you take, the oxidation state of the particular element will be 0 for it whenever it is present in the elemental state. In elemental state, for any element, its oxidation state will be 0. Next you see, for simple cations and anions, for simple cations and anions, charge on them is their oxidation state. For simple cations and anions, charge on them is their oxidation state. Sir, how it is possible? Means see, Na plus, Mg2 plus, Al3 plus, Cl minus, O2 minus, N3 minus. What is the oxidation state of chlorine? Means -1. Oxygen is -2. Nitrogen is -3. Sodium is +1. Magnesium is +2. Aluminium is +3. Like this, whenever you take single or simple cations and simple anions. If you take OH minus, for OH minus, what is the oxidation state of oxygen? Means it is not equals to -1. For simple cations means single cation or single anion, or ions which is having single atom are known as the simple ions. For simple ions, oxidation number is equals to the charge present on them. Next you see, for some elements we will see, this you have to remember, first A group elements oxidation state is +1. What are the first A group elements? Means sodium, potassium, rubidium, cesium and then francium. I told you how to remember the mnemonic also. For second A group elements, it is always +2. Beryllium, magnesium, calcium, strontium, barium and then radium. Anything you take in any circumstance, in any compound, first A group element is there means its oxidation state is +1. Second A group element is there means its oxidation state is +2. For fluorine, it is always -1. Except in HOF. HOF, according to the NCERT, fluorine will be present in the +1 oxidation state. This is an exceptional thing. For hydrogen, you see, two hydrogens compounds are there, metal hydrides and non-metal hydrides. So let us see, for metal hydrides means metals react with hydrogen to form the metal hydrides. Example is NaH and then CaH2. CaH2 is known as hydrolith. Hydrolith means whenever we are producing hydrogen gas, because of its light weight, it is not possible to transport the hydrogen gas from one place to another place. That's why we will be using this CaH2. CaH2 is known as hydrolith. This is a very important CBSE question mark. What is hydrolith? They will be asking you. See, what is hydrolith means? Hydrolith is nothing but the calcium hydride. So in metal hydrides, where hydrogen reacts with metals and forms compounds, its oxidation state is -1. When non-metal hydrides are there, its oxidation state is +1 always. So for first A group elements it is +1, for second A group elements it is +2, and for fluorine it is always -1, except in case of the HOF, where it will be showing the +1 as per the NCERT, but still it is under discussion only. And hydrogen, two compounds, metal hydrides are there and then non-metal hydrides are there. In metal hydrides it will be showing the -1 oxidation state, and in the non-metal hydrides it will be showing the +1 oxidation state. So these are the basic rules, and still so many rules are there. Let us get into them. Hope you have taken down this thing. I am rubbing this part. Right. Next you see, for oxygen. Oxygen will be having different compounds, so it will show the different oxidation state. Let us see. Oxygen in oxides, peroxides, superoxides, monofluorides and difluorides. See, oxides are like H2O, CO2 and SO2. Like this, any oxide you take, it will be showing the -2 oxidation state. Peroxides are H2O2, Na2O2, BaO2. In all of them, it shows the -1 oxidation state. In superoxides, KO2 and CSO2, it will be showing the -1/2 oxidation state. Monofluorides, O2F2, it will show the +1 oxidation state. Oxygen difluorides, it will show the +2 oxidation state. Like this, in different compounds, it will be showing the different oxidation states. So see, of difluorides, OF2, they will ask you in which of the following compounds oxygen can show the +1 oxidation state, oxygen can show the +2 oxidation state. Like that they will be asking you. And next one you see, mostly for nitrogen, nitrogen will show so many oxidation state, but in metal nitrides, it will be showing the -3 oxidation state commonly. Like this, these are the fundamental rules to calculate the oxidation state for any species. By using these fundamental rules, you can calculate the oxidation state for any species. But see, if you are following my videos properly, means in chemistry especially, in mains exam, definitely you can score more than 80% marks. In your local competitive examinations, you can score more than 85% marks in your chemistry, not 85 also. More than 90% marks you can score in your local state board entrance examinations if you follow my videos properly. Actually, my main focus of teaching will be like that only. So try to follow the points very carefully. Right. Let us see some examples. How can we calculate, or how can we calculate the oxidation state? Let me give you some compounds. The question is, find oxidation state of underlined element in following species. So this is the question they will be asking you. So see, KMnO4, H2SO4, HNO3, K2Cr2O7, SO4 2-. So these are the species what we are having. You have to calculate the oxidation state of the underlined elements. So let us see how to calculate. We know the one statement in the starting of oxidation number. I have told you, algebraic sum of the oxidation state of all species in a compound is equals to the charge present on them. Here the charge present on them is 0. Here 0. Nothing is present means there will be 0. But here -2 is there. Let us see. Potassium oxidation state is +1. Manganese you take it as plus. 4 oxygens are there. Oxygen oxidation state is -2 equals to 0. So that's why x minus 7 is equals to 0 and x is equals to +7 will come. Like this we can calculate the oxidation state for the KMnO4. For H2SO4 how can we calculate? Means hydrogen 2 into +1, it is +2. Sulfur we don't know, x plus 4 into -2 equals to 0, x minus 6 equals to 0 and x equals to +6 will come. HNO3 you see, what is the hydrogen oxidation state here? Generally hydrogen with non-metallic compound only, so +1. Nitrogen we don't know, so we take it as x. Oxygen oxidation state is -3. So plus 3 into minus 2. Total charge on them is 0. So x minus 5 equals to 0 and x equals to plus 5 will come. K2Cr2O7. Potassium oxidation state is plus 1. So plus 2 plus 2x plus 7 into minus 2 equals to 0. 2x minus 12 equals to 0. X equals to plus 6 will be coming. Like this, whatever the algebraic sum is there, we will take them equals to the charge present on them. Here you see this is an anion. X plus 4 into minus 2 is equals to minus 2. Why it is equals to minus 2? Charge present on the sulfate ion is minus 2. So that's why it is equals to minus 2. So x minus 8 is equals to minus 2 and x equals to plus 6 will come. So like this we can calculate the oxidation state of the species underlined by using this method. So what is oxidation number? What are the properties of oxidation number? What are the basic rules to calculate the oxidation number? What is the procedure to calculate the oxidation number? Hope you understood this thing. Let's take down this up to here. Hope you have taken down this thing already. So I am rubbing this one. Like this, by using these rules, any compound oxidation state you can remember. And there are some exceptional compounds are there. For them also I will tell you how to calculate the oxidation number. Let us see C2O4 2 minus NH4 plus. So for these compounds, how can we identify? These are the normal compounds only. 2x plus 4 into minus 2 equals to minus 2. 2x minus 8 equals to minus 2. X is equals to, what will be coming here? 2x is there. 4 into minus 2 equals to minus 2 will come. So x equals to plus 3 will come. In this case, nitrogen you take it as x and plus 4 is equals to plus 1, x is equals to minus 3 will come. Like this we can calculate the oxidation state. And let us say in hydrozoic acid, the formula of hydrozoic acid is N3H. In N3H, what is the oxidation state of nitrogen means? Listen carefully. In N3H, 3x plus 1 is equals to 0, x is will come. So oxidation state can be fractional also. So be careful with this thing. Let us see for DMSO. DMSO means dimethyl sulfoxide. The structure of this is S double bond O CH3 CH3. Whenever there is alkyl group, CH3 is there. Normally CH4 will come. If it loses H minus, then it will form CH3 plus. Always remember, for oxidation state of CH3 will be plus 1. This you have to remember. So here you see x plus 2 minus 2 equals to 0 and x equals to 0 will come. Like this, some exceptional compounds will be there. For them we have to remember the oxidation state. No need for organic cases. If you see methyl group is there, for that methyl group oxidation state is plus 1. If you can remember that one means we can do the problems on this thing. So these are the common examples. There are some exceptional compounds are there. How to do the oxidation state for them also we will discuss. Take down this for 1 minute. we have taken down this thing. Let us get into the exceptional compounds. Let us see for some exceptional compounds. Exceptional compounds means compounds with bonds between same atoms. This is one kind of exceptional compound, and other type compounds is compounds with peroxide linkages and complex compounds. So exceptional compounds which will be beyond the given rules. Of course they are in the limits only, but some additional rules you have to add on, some additional procedure you have to do. That is, see, compounds with bonds between same atoms is CH3, CH2, CH3, CH3, CH2, CHO, CH3, COOH, Br, 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 double bond O, 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 Br3 OH. This is NCERT example, so you have to remember this very carefully. C double bond O, double bond O. This is also NCERT. C3O2, carbon suboxide we call it as carbon suboxide. So like this, whatever the compound you take which is having bonds between similar atoms. See, whenever there are compounds with bonds between same atoms, break the bonds. This is imaginary mark. Break the bonds. This is a technique how to remember them. Wherever there is bond between similar atoms or same atoms, break the bonds. And treat every fraction as an independent molecule. The first one is break bond. Second one is treat every fragment as independent molecule with zero charge. So break the bonds, treat every fragment as a independent molecule with zero charge, and by using traditional procedure identify the oxidation state. So this is a fragment X, carbon you have to identify, so it is X plus 3 equals to 0 and X is equals to minus 3. Sir, you told us CH3 will be carrying the positive charge. Of course it carries, but this is now as a compound it does not carry any kind of special charges. So here I am just telling you a method how can you identify the oxidation state of a particular species or particular carbon atom whenever it is present individual fragments, whenever they are asking you individual things. Here this fragment is there, this is X plus 3 equals to 0, so it is minus 3. Here X plus 2 equals to 0 and X equals to minus 2. X plus 3 equals to 0 and X equals to minus 2. Done. Finished. Here you see, here it is minus 3, minus 2. Here x minus 2 plus 1 equals to 0 and x equals to plus 1 will come. You know, in the IUPAC nomenclature, this gets the first priority. So in the IUPAC name case, first carbon is plus 1, second carbon is minus 2, third carbon is minus 3 will come. In this case, what will come? Minus 3, x minus 4 plus 1 equals to 0 and x is equals to plus 3. I am taking every component as a neutral fragment and I am calculating. Here bromine will be having plus 6 oxidation state, plus 4 oxidation state and plus 6. Here it will be having plus 2, 0 and plus 2 oxidation state. Like this. These are the compounds with bonds between the same atom. This is a different species. So whenever you get compounds with same bond or bond between same atoms, you have to break the compound into fragments and you have to consider every fragment as a separate neutral molecule, and by using the normal procedure you can calculate the oxidation state. Next you see compounds with peroxide linkages. So how to identify the particular compound with peroxide linkage? There is no need to by heart also. CrO5, H2SO5, H2S2O8, H3PO5. How to identify that peroxide linkage means? There is no need to, actually you have to by heart the structure, but if you forget that structure means I will tell you a technique, based on that you can do the rest also. See, CrO5, by using the traditional method, if you calculate oxidation number for this, you will be getting plus 10 will come, because x minus 10 equals to 0 and x equals to plus 10 will come. In this case you will be getting as plus 8 you will get. In this case also you will be getting as plus 7. In this case you will be getting as plus 7. But originally chromium plus 10, sulfur plus 8, sulfur plus 7, phosphorus plus 5. The maximum electrons available in chromium is 6 only. How can it donate 10 electrons? That means the answer you are getting is wrong. So like this you have to put breaks for your calculation during the examination. So whenever they are having peroxide linkage itself, this CrO5 is known as blue perchromate. Whenever chromium chloride is treated with hydrogen peroxide in basic medium, it will produce a blue color solution which is known as blue perchromate. They will give the reaction and they will ask you what is the oxidation state of the chromium in the final product. So you should be very, very careful about that. And you see H2SO5, 8 electrons. How can it get 8 electrons? Its valency configuration is 3s2, 3p4 only 6 electrons possible. How it can donate 8 electrons? That is impossible. Then you have to get in your mind that it will be having the peroxide linkage. As I told in oxyacids part, this is known as Carros acid and this is known as the Marshall's acid. So let's get into the details. CrO5, the structure is butterfly structure. H2SO5, S double bond O, OOH and then OH. H2S2O8, S double bond O, OO, S double bond O, OH and then OH. H3PO5, double bond O, OH and then OH. So like this, whenever there are peroxide linkages in any compound, we consider the contribution from them as -1. The other will contribute -2, -1, -2, -2, -2, -2, -2, -1, -1, -2, -2, -2, -2, -2, -1, -1, -2, -2. So like this, the contribution from peroxide linkages will be -1. If you calculate oxidation state, +5 will come for this thing, +6 will come for this thing, +6 will come for this thing, and +6 will be coming for this compound. Like this, whenever there is alarming case. How to identify the alarming case means when you find the oxidation state for that, it will be coming beyond its valency electrons. From that you should get a break for your calculation and you have to get this answers. And finally, complex compounds. What are the complex compounds means? K4FeCN6. Like this, any compound which is they are mentioning square brackets, we call it compound as a complex compound. In the complex compounds, a group of atoms will come, that is known as ligand. A group of atoms will be coming which are known as the ligand. So this ligand, some people will pronounce it as ligand and some will pronounce it as ligand. There is no issue at all. So see, these ligands will have particular charge, like Cn minus, NO2 minus, and then C2O4 2 minus, CO3 2 minus, F minus, Cl minus, Br minus, I minus, like this, OH minus, SH minus, NO2 minus, like this, with different charges they will be present. Whatever the charge on them, that whole will become the oxidation state. So this will be plus 4 plus X minus 6 equals to 0 and X is equals to plus 2 will come, like this. Whenever their ligands are there with the different charges, you have to remember the charge on them. If you see H2O, NH3, CO, CH3, NH2, all these are known as the neutral ligands. So they will be having no charge, and NO is there. NO will carry plus 1 charge as well as 0. NO plus will be present in the brown ring complex. In brown ring complex, NO will be bearing the plus 1 oxidation state. This is very, very important one. For confirmation test for the nitrate ion, we will be using the brown ring test. In that brown ring test, NO will be coming as a final product. So in that brown ring complex, what is the charge on NO means it will be plus 1 charge will be coming, and iron will be bearing the plus 2 will be coming. Like this, we can identify the oxidation state for the general complexes and compounds with the bonds between the same atoms, which is having peroxide linkages, and how to do the things for the complex compound. So that is the thing regarding the oxidation number calculation. So what is oxidation number and how can we calculate the oxidation number for the different elements? Clear? Take down these. What are the applications of the oxidation number means we will discuss. This you take. As I told you, in the oxo acids case, oxidation state of the central atom decides what is the strength of the acid. So by using this procedure, you can easily identify what is the oxidation state of the particular central atom. And after this thing, we can easily identify which will be strong acid and which will be weak acid. Take down this. Okay, right one. Hope you have taken this thing, and let us get into the applications of oxidation number. See the first one. Strength of acid. Since we know this already, I will explain. Strength of acid. Strength of acid is directly proportional to oxidation number. If you take HClO4, HClO3, HClO2 and HClO, which is a strong acid means plus 7, plus 6, 5, plus 3 and plus 1. So that's why HClO4 is more acidic than HClO3 greater than HClO2 greater than HCl will come. That is one of the application. Second one, strong oxidizing or reducing agents. Strong oxidizing agents, strong oxidizing or reducing agents can be identified. So how we can identify whether a particular species is strong oxidizing agent or strong reducing agent? By using the oxidation number concept. Let us see MnO4 minus Cr2O7 2 minus. Here you see manganese is present in +7 oxidation state. This is present in the +6 oxidation state. A species present in highest oxidation state is strong oxidizing agent. So see, the manganese maximum oxidation state possible is +7 and chromium maximum oxidation state possible will be +6. Since manganese and chromium are present in the possible highest oxidation state, they both behave as a strong oxidizing agents. A species present in lowest possible oxidation state a species present in lowest possible oxidation state is reducing agent. So we know metals are there, sodium, potassium and then lithium. So when you take these sodium, potassium and then lithium, what happens? They are present in a lowest oxidation state, that is 0. So they behave as a reducing agent. If oxidation number is in between highest and then lowest, it can undergo disproportionation. So if oxidation number is between highest and lowest, means it can undergo disproportionation. Let us take for example SO2. SO2 case, sulfur is present in the +4 oxidation state, and you take Mn+4. Mn also present in the oxidation state in between. So Mn+4 can become Mn+7 and it can become Mn+2. So it can undergo disproportionation. But Mn+7 only it acts as a oxidizing agent. There is no reducing behavior for MnO4-. Why? To show the reducing behavior, it has to donate electron, but there is no chance for it to donate. So when a species is present in its highest oxidation state, it only acts as oxidation state. If a species is present in the lowest possible oxidation state, it only acts as a reducing agent. You have to keep this in very important note. Here, based on this only number of reactions they will ask you, and you see we can identify whether the reaction is oxidation or reduction also by using the oxidation number. If oxidation number increases, means it is oxidation reaction. Oxidation number decreases, means it is reduction reaction. If both are happening, means it is a redox reaction. So to identify the oxidation and reduction reactions also, you can easily identify. And in some reactions they will ask you, in which of the following reactions H2SO4 acts as oxidizing agent? In which of the following reactions H2SO4 act as, there is no possibility. In which of the following reactions H2BO2 behaves as a reducing agent? In which of the following reactions SO2 behaves as a reducing agent? For that reactions, there is no need to worry about anything. Find the oxidation state. If it is increasing its oxidation state, means it is a donating electron, so it is a reducing agent. present. If it's decreasing its oxidation state means it is taking electrons, so it is a oxidizing agent. By simple logic you can identify. There is no need to by heart that reaction also. So in inorganic chemistry there are so many reactions which shows H2SO4 as a oxidizing agent, where SO2 behaves as oxidizing agent, SO2 behaves as a reducing agent. What are those reactions means I have very great confusion means there is no need to have any confusion. Look at the oxidation state of the particular species, whether it is increasing or decreasing, automatically you can do the problem. So like this we are having this oxidation number with so many applications. So that's why this is a very, very important thing. So that is about what is oxidation number, what are the basic things about the oxidation number, how to calculate oxidation number, basic rules are what, and how to calculate oxidation number for some typical compounds with similar atom bond linkages, with peroxide linkages. For complex compounds, how to identify mixed oxides. Let us take for example PB3O4. Here PbO plus 2 PbO and then PbO2 is there, where lead will be present in +4 oxidation state and +2 oxidation state. For this type of compounds you have to by heart the procedures. And if you see Fe3O4, in Fe3O4 also FeO is there and Fe2O3 is present. In this type of compounds you have to identify. Here iron is present in +2 oxidation state and then +3 oxidation state. Here it is present in +2 oxidation state and +4 oxidation state. And one more is there, that is CaOCl2, that is bleaching powder. CaOCl2, where chlorine will be present in +1 oxidation state and then -1 oxidation state. This kind of exceptional compounds are there which you have to remember. Those things you can't do anything about. So in bleaching powder, what is the oxidation state of chlorine, they will ask you, that is +1 and then -1. In Fe3O4, what is the oxidation state of iron, they will ask you, +2 and then +3. In Pb3O4, what is the oxidation state of lead, they will ask you. If you calculate means it will come in fractions, which is not reasonable thing. So you have to by heart for thing. If you see lead, for lead +2 is a stable oxidation state or +4 is a stable oxidation state, means as you move from top to bottom, always the oxidation state try to decrease by 2 units compared to the top element's oxidation state. That is because of the inert pair effect. Whenever you see 6th period and 7th period elements are there, whenever you are jumping from 5th period to 6th period elements, because of lanthanides, because of their poor screening capacity, nucleus holds valence s electrons very tightly. That's why they does not involve in the donation, and hence they will not participate in the reaction, and this is known as the inert pair effect. Inert pair effect, in the next session I will make a video, in that I will explain very clearly. So that's why for lead +2 is the most stable oxidation state, +4 is the less stable oxidation state. So this kind of things also they will ask you based on this oxidation number. So that is the thing for today's video. If you like this video means click the like button. If you want to share this with your friends means share the video. To get more notifications from my channel, click the subscribe button and click the bell icon. Thank you.